Welcome to the 9th video on building our air motor. Today we focus on the engine block. At first glance, the engine block may seem quite complex, but it is based on functions already familiar to us. The key to success lies in a structured approach. In this video, we introduce new tools that help you create a clearer structure, such as renaming sketches and creating groups in the design timeline. In addition, we use half sections to control the design of our engine block. We also show you an alternative method for creating a thread using the threading function instead of the conventional drilling. Have fun rebuilding and discovering new possibilities. As always, there are different ways to design the engine block. This time we start with the side view in the YZ plane, which is shown as a sectional view in the drawing. We start again at the origin and trace the rough contour of the engine block. If you want to make it easier for yourself, you can, similar to the crank pin, upload the drawing of the engine block as an image and trace it directly. By starting in the side view, we can capture a large part of the contour in the first sketch. This allows the engine block to be constructed with relatively few elements, increasing clarity and making later adjustments easier. Afterward, we'll add all the missing dimensions until the sketch is fully defined. We extrude the finished sketch evenly in both directions by setting the direction to symmetric. It's important to switch the measurement to total length before entering the distance of 25 mm. To check the extrusion, we simply click on an outer edge of the motor block and then see the exact length at the bottom right. Since we will be adding more sketches soon, it is important to keep track. Therefore, it is advisable to give sketches descriptive names. To do this, right-click on the desired sketch in the browser and select Rename. Assign the name Base Body, for example. Next, we will focus on creating the hole for accommodating the crankshaft using the hole function. For this, we position the hole on the appropriate surface. Since we previously extruded our sketch symmetrically, we can use the YZ plane as a reference to position the hole centrally. Then we fix the drilling by selecting the bottom edge of the engine block as a second reference and marking a distance of 10 mm. For the boundary option, we select All so that the hole runs completely through the component. For the hole type, we choose a simple hole and specify a diameter of 8 mm. Now we apply this procedure to the large bore for the piston as well. The distance to the front edge is 11.5 mm here. After aligning the bore, we can choose a simple bore with a diameter of 14 mm. Now it gets a bit more challenging when creating the ventilation bore for the piston. Position the bore also on the top surface of the engine block. The distance to the front edge is 24 mm, and for the limits we choose the option All. For the drilling type, we decide on a cylindrical countersink and set the diameter of the countersink to 4 mm. We set the countersink depth to 30 mm and the hole diameter to 2.5 mm. Next, we will create the groove for the piston ventilation. For that, place a new sketch on the top surface of the engine block. Then select the function Slot Center to Center and draw a slot from the center of one hole to the center of the other. We set the width to 4 mm. Finally, extrude the slot with a depth of 2 mm. We can call the sketch long slot for better clarity, for example. Now, we create the side threaded hole. We first make it as a simple through hole and then add the thread. To do this, place a through hole on one of the side surfaces of the engine block and position it as before using body edges and body surfaces as a reference. Finally, we confirm the drilling with a diameter of 4 mm. Next, we complete the drilling by creating a thread. To do this, we select the Thread command under Create and click on the previously created hole. Then, select an M5 thread and confirm the process. This is how you have learned to easily add threads later on without using the drilling function. In this case, we could have created the thread directly with the drill command, but the function will be useful to us later. Only the holes for the screws to attach the cylinder head plate and the mounting bracket are missing. Begin with the holes for the M4 hex socket screws on the underside. One of the holes is already there. We will now create the second one by positioning another hole on the underside. We create this hole with a diameter of 2.5 mm and select 2 as extent. To do this, we click on our side M5 thread hole, so the new hole is created exactly up to that point. Next, we select both drillings and navigate to the Thread command again. We create 2 M4 threads and confirm the process. Now, we add the M3 drillings on the top side of the engine block for the cylinder head plate. Create a sketch on the top of the cylinder block and draw a rectangle with the dimensions 14 by 21 mm. Use the symmetry over the y-axis and the distance to the component edge to position the rectangle. After we have completed the sketch, we use the drilling function to select the corners of the rectangle and create an M3 threaded hole with an offset. We set a drilling depth of 9 mm and a thread depth of 6 mm and confirm. Here too, we can rename the sketch, for example, to drilling positions to maintain clarity. You've finally completed all the holes and threads. Congratulations! Lastly, only the chamfers and rounds are missing. We'll add these as usual. Now, everything will be organised. To make our construction clearer, we group all elements belonging to ventilation. Click on the first drilling hole, hold down the Control key, and select all other elements related to ventilation. Right-click to select Create Group. You can then rename this group. If needed, you can expand or collapse the group. Grouping is particularly useful for larger constructions to maintain an overview. To verify if you have correctly implemented the cutouts for the air motor's ventilation, we use a sectional view that allows us to look inside the motor. Select Check and then Section Analysis. Then, choose the YZ plane to set the position of the section. Now you see the engine block in the cross-section and can check the cutouts for ventilation. Alternatively, you can move the cutting plane with the blue arrow to view the entire engine block in the cross-section. In our case, we set the cutting plane on the YZ plane and confirm. We see that all the necessary holes are connected to each other. Now you can show or hide the cut in the browser under Analysis at any time to check your engine block. As usual, you make final adjustments to the material. Select aluminum for your engine block. Also, don't forget to save. To conclude, let's summarize everything once more. In this video, we mainly practiced structured and clear work. We learned to rename sketches and create groups in the construction process to improve clarity. Additionally, we used the half-section function to better control our construction. We learned about different alternatives for creating threads. Especially the tips for organized work will help you later on to not lose track with more complex components. Stay excited for the next steps. Good luck with creating the other components.